Hi, Assalamualaikum. In this video, we are going to discuss example 2 from previous semester papers under linear equation. Solve the following linear differential equation dy over dx minus y over x equals to x squared e the power of 2x. Okay. From this question, we have y the power of 1 and there is no term containing y the power of 2, 3 and so on. Okay, so means that this is linear equation. Okay, under linear equation, first step, we write into the form of dy over dx plus pxy equals to qx. Okay, so from the given question, we can write dy over dx plus, because from the standard form, we need to write plus sign here. Okay, so we can write plus and then in bracket negative 1 over x, y. Okay, we separate terms containing x and y. Okay, and then right hand side equals to x squared e the power of 2x, which is term not containing y. Okay, alright, from here, okay, we can continue with step 2. Okay, identify px and qx. Alright. Okay, now our coefficient of dy over dx equals to positive 1. So we can compare 1 by 1. Okay, our px equals to negative 1 over x. Before that, the sign should be positive. Okay, before px. Okay, so our px equals to negative 1 over x. Okay, and then our qx equals to x squared e the power of 2x. Alright. And after that, we can continue with step 3. Okay, find integration of px dx. Okay, so integration of px dx equals to integration of negative 1 over x dx. Okay, we replace px equals to negative 1 over x, and then we can move out negative sign outside integration symbol, so we have negative integration of 1 over x dx, so we have negative ln x. Okay, when we integrate 1 over x, it becomes ln x. Okay, plus c, but we don't need to write plus c when we find integration of px dx. Alright, and after that, we have coefficient of ln equals to negative. Okay, so we need to move up to the power here. Okay, so we have positive ln x the power of negative 1 here. Right? This comes from properties of log. Okay, p log am equals to log am the power of p. Okay, we can move constant in front ln. We can move up here. Okay. Okay, then we can continue with step 4. Okay, integrating factor if equals to e the power of integration of px dx. Okay, so from this formula, okay, we can write integration factor equals to e, and then we replace integration of px dx obtained in step 3 equals to ln x the power of negative 1. Okay, and then it is equals to x the power of negative 1. Okay, so this comes from formula e the power of positive ln x equals to x. Okay, if we have e the power of ln x, it becomes x. So if we have e the power of positive ln x the power of negative 1, it becomes x the power of negative 1. Okay, that's why it is important to make coefficient of ln equals to positive. Okay, so that we can use this formula to simplify. Alright. Okay, and then we can write x the power of negative 1 equals to 1 over x. Okay. Okay, then step 5, we can write the solution using formula y times if equals to integration of qx times if dx. Right? So from this formula, we have y here and then times if. Okay, if equals to 1 over x and then equals to integration of qx. Okay, qx equals to x squared e the power of 2x from step 2. Okay, and then times if. Okay, 1 over x from step 4. Right? And after that, we can simplify. Okay, so we have integration of x e the power of 2x dx. Okay, and then from here, okay, from right hand side, we need to integrate. Okay, we don't need to integrate left hand side because there is no integration sign here. Okay, so we just integrate the function on the right hand side. Okay, so for right hand side function, we need to integrate x e the power of 2x dx. Okay, using integration by parts. Okay, and from integration by part, if we have repeatable function such as exponential function or trigonometric function, we can use tabular integral. Okay, so using tabular integral, we have 3 columns. The first column is sine and then u and then dv. Okay, for column u, we need to differentiate. Okay, and then for column dv, we need to integrate. Okay, so first, we need to identify which function as u and which function as dv. Okay. Okay, from here, we have combination between x and e the power of 2x. So, x here is a algebraic function. Okay. And e the power of 2x here is e exponential function. Okay. And then from Liat formula or Liat formula, okay, we can use Liat or Liat, L-I-A-T-E. Okay, so from Liat or Liat formula, okay, A come first. Okay, between A and E, okay, A come first. Okay, from this word. Okay, so the function that comes first from the word Liat, okay, become u. Okay, so means that a, which is x, become u. Okay, and then the other function should be dv. Okay, so after we identify the function as u and the function as dv, we complete column u first. Okay, in column u, we need to differentiate. So we differentiate x, it become 1. And then we differentiate 1, it become 0. Okay, so from here, okay, we can stop. Okay, if we have algebraic function, when we differentiate, okay, until the derivative gives 0, so we can stop the row. Okay, and then we continue with column sign. Okay, we must start with positive sign first. And then we alternate with negative and then positive. Okay, and after that, we complete column dv. In column dv, we need to integrate. So from e the power of 2x, we need to integrate. Okay, we use formula integration of e the power of ax dx equals to 1 over a e the power of ax plus c. A is constant. So now our a is 2. So from this formula, we have 1 over a, which is 1 over 2, e the power of ax, which is e the power of 2x plus c. But in this column, no need to write plus c. Okay, and then from half e the power of 2x, we integrate again. Okay, so we still use this formula. So we have half in front and then we integrate e the power of 2x. We still have half e the power of 2x. So half times half become 1 over 4 e the power of 2x. Okay, now we complete the table. Okay, so after that, we can write integration of x e to x dx equals to, okay, we multiply this, okay, we multiply x and half e the power of 2x. So we get this, right? Then we multiply 1 times 1 over 4 e to x. We get this, okay? And then we multiply 1 over 4 to x e to x times 0. Okay, so we get this. But for the last row, we need to put integration sign. Okay, so when we multiply 1 over 4 e the power of 2x by 0, it becomes 0. Okay, for the last row, we need to multiply straight. Okay, and we need to put integration sign. Okay, and after that, okay, we multiply the sign. Okay, positive times positive times positive. Okay, equals to positive sign here. Okay, and then negative times positive times positive equals to negative sign here. And then positive times positive times positive. For the last row, we multiply straight. Okay, equals to positive sign here. Okay, then we simplify. So we have positive half x e the power of 2x minus 1 over 4 e to x plus, when we integrate 0, it becomes constant. Okay, because when we differentiate constant, it becomes 0. Right? And then we can substitute here. So we have y over x equals to, when we integrate x e the power of 2x dx, okay, it is equals to half x e the power of 2x minus 1 over 4 e to x plus c. Okay, after that we can write y as a subject. So we have half x squared e to x, and then minus 1 over 4 x e to x plus cx. C is constant, okay, and x is variable. So c, we need to multiply with constant. But if c and constant, we no need to multiply because c times constant also equals to constant. Okay? Right? So this is the final answer. Okay? This is the solution. Okay? The final answer free from dy over dx symbol because we integrate. Right? Okay, so from here to here, we integrate using integration by parts. Okay. Coming up next, more examples for linear equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.